Hi friends! So I want to recap your lab over Newton's first law of motion. So let's walk through each activity, make sure you saw what you're supposed to saw, and for those of you that didn't get a chance to do this lab, this is a great opportunity for you to see what you're supposed to see and learn from it too still. So in activity 1, it was called Magic Hoops, and what you did is you put these chips on top of an index card, and you tried to get the chips into the cup without touching the chips. This is an example of law of inertia. I'm just going to keep playing it on loop. It's supposed to loop, but there we go. This is an example of Newton's first law of inertia because the chips weren't acted on by an outside force, by an unbalanced force. They were acted on, the forces that were acting on the chips were the force of the index card pushing up and the weight of the chips pulling down. But the force that was applied in this situation was to the index card, and it was going this way. So that the forces have to act in the same direction. So because the force wasn't acting on the chips themselves, they were acting on the index cards, then the chips were going to keep doing what they were doing, which was sitting there. But because the index card was removed, they couldn't sit there anymore, so they fell through into the cup until they stopped by another force, which was the cup pushing on it. So remember, first law is, or if you haven't learned it yet, here it is. First law of inertia, or the law of inertia, Newton's first law of motion is objects will continue doing what they're doing, for lack of a better term. It's not very technical, but they'll keep doing what they're doing until acted on by an outside force. So objects in motion will stay in motion, objects at rest will stay at rest until acted on by an unbalanced force. And in this situation, the unbalanced force acted on the index card and not on the coins. In activity 2, we did the tablecloth trick with wax paper and a water bottle. But everybody's seen it where you've taken away a tablecloth and you rip it out from everything underneath and everything stays on top. Well, it's the same concept. Objects in motion, objects at rest will stay doing what they were doing until acted on by an unbalanced force. So the water bottle was sitting on the table on top of the wax paper. Well, the force wasn't applied to the water bottle, it was applied to the wax paper, and so that's why it didn't really move. It moved a little bit because of friction, and you see the water moving in the video too, but it didn't move all the way off the table with the tablecloth, with the wax paper, like you would have thought. In activity 3, this was chopping block. You set up a stack of Jenga blocks and you had to chop out the bottom one without moving the rest of it. This is another example of law of inertia because the unbalanced force is being applied only to the bottom block, not to the other blocks. And so the other blocks are going to keep doing what they're doing, which is resting in that position. Now they move down because the force of the bottom block isn't there to push up, and so it removes, and then they stop again when they hit the table, and the table applies a force. In activity 4, we called it Inertia Joe because we have a little G.I. Joe figurine here. Loop these two. G.I. Joe here was showing us the importance of seatbelts. So in the first video right here, oh, I didn't loop it. There we go. In the first video, our little Army action figure is not wearing a seatbelt, and so even though they move together while the car is moving, the books stop the car and not G.I. Joe, not that Army action figure, in case you don't know what G.I. Joe is. So that's why the Army action figure goes flying. Same thing that happens to you if you don't wear a seatbelt. You go forward and you either hit the seat in front of you or you hit the dashboard in front of you, and that's the thing that stops you. That's the unbalanced force that acts on you to get you to stop. When the Army figurine was wearing a seatbelt, aka a rubber band, you can see that the force was applied now to both the car and the figurine. So the unbalanced force acted on both of them, which meant both of their motions stopped. So law of inertia is the whole reason why you need to wear a seatbelt. And then in the last activity, this was a very, very silly activity, but it's a lot of fun, right? This is called Spin the Human, and what this student is wearing is an inertia hat. It's just a wire hanger with tennis balls on the end that have it balanced out. And you'll notice that when she spins the inertia hat, nothing really happens to her, and she is able to move the opposite direction without it affecting the inertia hat either. And this is because the unbalanced force was applied to the ball and not to her head. And likewise, when she was spinning, she was applying the force to herself and not the hat. So everything kept doing what it was doing because the unbalanced forces, were acting on opposite things. So there you have it, law of inertia. Objects in motion, objects at rest will stay at rest or in motion until acted on by an unbalanced force. If you stayed on this long to see me stop this video, I'll see you later.